All right, this is an exponential decay problem. Exponential growth problems are done in a similar way. But what we're told here is we're given an initial amount of some radioactive material. It decays over time. We got 200 grams of it. The half-life, we're told, is 30 days. And the question is, how much are we going to have? How much of this is going to be left after 50 days? All right, well, here's our formula for exponential growth and decay. If it's exponential growth, K will be positive. If it's decay, it turns out K is negative. But the idea is the same. What are we told? Well, the half-life is 30 days. So that means P, so P is the amount, the population size after time T. P0, this is the initial amount. K is the number we need to try to find to solve the problem. So the initial amount is 200. We plug that in here. Half-life, well, that's the amount of time it takes for what you start with to become half. Well, half of 200 is 100, so this will be 100 after 30 days. So then we plug in 30 for T, we get e to the 30k, or k times 30, same thing. Now we solve this for k. So we first divide both sides by 200. These cancel, and we get e to the 30k equals a half. So we get e to the 30k equals a half. This is an exponential equation with e, so we take the natural log of both sides. The natural log of e to the 30k equals the natural log of a half. But by the properties of exponents, the natural log of e to the 30k is 30k. So we get 30k equals the natural log of a half. And then we divide both sides by 30. And there's our value of k. Now sometimes some people simplify this. Let me do that. You can use this, there's no problem with that. You can plug that in for k, but let's simplify. Remember, the natural log of a fraction, the natural log of a over b, equals the natural log of a minus the natural log of b. The natural log of 1 minus the natural log of 2 over 30. Well, the natural log of 1 is 0. You can verify that a few different ways, but if you plug it in your calculator, you'll see. So this simplifies to 0 minus the ln of 2 is minus the ln of 2 over 30. So that's the value I'm going to use for k. Again, this does not simplify to, like, I don't know, ln over 15. That's our answer. So now we go back and we plug that into this equation. We plug k in. So we get p equals p0 times e to the kt, but for k, we're plugging in minus the ln of 2 over 30. And then that's multiplied by t. Okay, so the first step is to find the value of k. There it is. The second step is, well, how much is left after 50 days? So all we got to do now is plug in 50 and plug in how much we start with. Well, in this case, we're starting with 200. So P is 200 times e to the minus ln of 2 over 30 times t, and again, this question is how much is left after 50 days. Now here, you just got to plug this into your calculator. And when you plug that into your calculator, you're going to get a number that's about 63. So after 50 days, the initial amount of 200 is going to be equivalent, the strength of it will be equal to 63 grams of that. So that's our answer, 63.